Hey everybody, welcome back to another episode in Software Engineering in Salesforce. My name is Brooks Johnson, and today we're going to do some LeetCode. I was ever asked was to solve a problem like this. And I don't know how many LeetCode videos I'll make. I've kind of just started my own LeetCode journey, and I've really been enjoying it. But where there are things I think where it's particularly useful in the Salesforce industry, I think it's worth taking some time to stop and make a video and think about the algorithms that we're building. And particularly, take these LeetCode problems and implement them in Apex, because that's one of the challenges with a lot of, whether it's, LeetCode, HackerRank, etc., right? They don't use Apex because that's a proprietary language. It needs to run needs Salesforce to run. So it's a little extra work. I typically, when I'm LeetCoding, do my implementations in JavaScript, trying to do a little more in Java, and hopefully C soon too, trying to do a little more low-level stuff. But enough of that. Let's get into LeetCode. Let's get into number 217, contains duplicate. All right, so I have this. I have it open on my screen right here, and so we can see this is it's an easy problem, and that's all I've been working through on LeetCode right now are easy problems. And we're going to get an integer of array nums, an array of integers, pardon me, called nums. And we just have to say, is there a duplicate in it? So it's pretty straightforward, right? There's a duplicate in here. One is in there twice. Example 2, there is not a duplicate. Should return false. All right, this one's got a whole bunch of one, etc. That returns true. And then down here we can see some constraints, like, so you can see we might be getting passed in some pretty large lists, right? 10 to the 5th, and things like that. So let's go ahead and we're going to work through the first solution. I'm going to switch over to IntelliJ Illuminated Cloud. I'm going to do the first solution in Apex. And then we're going to come back. We're going to run the Java equivalent of that in LeetCode and see why it's maybe not the best. So let's hop on in there. Let's start writing some code. All right. So I have here ahead of time, I've got some unit tests written, contains duplicates tests. We're going to do 3 solutions today in this video to this problem. And right, so that one right now, right, we have our true and our false. We're going to pass in these lists of numbers, lists of integers, I should say. And I've got 3 stub methods. Contains duplicates 1, contains duplicates, contains duplicates sort. And we're going to talk about all 3 of those and what is their runtime. So I'm going to minimize my notation right there. All right, so first one, and this is, what some people here called, the brute force or the naive solution. And I always feel like naive is such a like a mean word, but it just really it's kind of like, like the easiest, the initial thing, the solution that would come to mind without having to think too hard about it. So we're going to say, we're going to just create a for loop, right? Integer I equals 0. We want it less than nums.size and I++. All right, and then we're going to just drop right down here. We're going to create another for loop. And I'm going to name that J. J is less than nums.size, J++. All right, and we are going to say if sometimes I think my autocomplete there hurts me more than it helps me. If nums at index I is equal to nums index j, return true. Else, down here, we would only get here if no duplicates were found. Return else. Whoop. My keyboard just went nuts. Only does that when I'm recording, so I wonder if this is starting to seem like a strong correlation. Return false. No duplicates were found. All right, so we just a nested for loop for integer I. All right, so first one we would just grab. Let me grab a We'll grab something with duplicates. All right. All right. All right, so it's just going to drop. Hey, okay. So I at index 0, that's going to be 1. It's going to drop down into this nested for loop. And actually, you know what? I'm sorry. I do want to do j plus 1. So integer j equals I plus 1. Because we don't need to compare it to itself. Why is my keyboard not I plus 1? There we go. All right, so then we're going to say, okay, you know, integer j, that's going to equal 2. So is 1 equal to 2? No. All right, it's going to, but, right, it's going to just continue to traverse the entire list. So it's going to go, is 3 equal to 1? No. Is 1 equal to 1? Yes, and it's going to return true. But we had to compare all the values. And, you know, and even this wasn't so bad because we had the, you know, our duplicate right there at the very beginning. But if you remember, like, this is a quadratic runtime equation. And I'll put a link up here to one of my other videos that I did earlier. But anytime you see a nested for loop, right, alarm should go off. This is a slow algorithm. So, you know what I mean? If you have 10 items, right, because it runs a quadrant, it's n squared. So if we have 10 items, right, it takes 100 steps. But if we make 20, if n equals 20, right, we didn't just double the number of steps our algorithm takes because of this nested for loop. It's 400 steps and so on and so forth. So if you are doing, and I should mention, if you're doing a coding interview, because I ask questions like this a lot, right? You may want to just hit on, hey, there's a brute force solution with a nested for loop, and explain like why it's not good. I wouldn't even bother whiteboarding it out, coding it out, whatever you're doing in that interview. I would just say, hey, this is a possible solution, and this is why I'm not doing it, right? That's all I'd really want to see as an interviewer. But it is correct, right? So by correct, I mean it does find duplicates. It's just not well designed. So we're going to push this. So we're going to run our tests. And our test should pass. Okay. I'm going to run test solution 1. Right there. Okay, so that passed, right? If we pass it in, that first one, you know, 1, 2, 3, 1, should find duplicates. We pass in the other one, it should not. So boom, let's go back to LeetCode. And I had this implementation of Java in there already, right? Nested for loop in Java. And so first, right, we'll go to LeetCode. We're just going to run it. And LeetCode's going to tell us, hey, it's accepted, right? Like with this little simple array, it passed. But if I submit this, I should see, like, right, like time limit exceeded, right? Like this just took too long. It's not, so it fails. And again, this is why you don't want to do, anytime you do these in an interview, I mean, if you're totally stuck, you can't come up with anything else, by all means, go for the brute force, go for a bad solution is better than no solution. So do that nested for loop. But ideally, you're going to move on and use better data structures to solve this problem. So what that means is let's go to our solution 2. All right, I'm going to uncomment this one out now so we have a test. I'm going to deploy it. There's nothing. And we'll go back to solution 2, which you can see right now is just stubbed out. There is absolutely nothing there. And so now for solution 2, and if you haven't, I encourage you, take a minute, pause the video. If you're only, right now, the only way you would solve this is with a nested for loop, take a second and try to work through this. How can we solve this problem without one? And so I'm going to say the key to that is either using a set or a map. I'm going to use a set. The technique here is called hashing, right? And that is, so sets and a map. The reason I say like a map has a key set, and that key set is just it's a set, right? It's the key set. And everything in there is hashed. And hashing is just a way that the computer can manage storage by saying, hey, this hashed value is at index whatever, and that lets our program retrieve values from a set or from the map in constant time. So what that means is we are going to do set. I know it. I can just use my hotshot illuminated cloud features. New set. New set integer. I'm going to just call it dupes, not duples. Dupes. New set integer. Right. All right. Now we're going to say for integer nums. If dupes contains num, so if our value is in that set, boom, that's it, we're done, return true. Then we are going to, for each value, so if we get down here, right, we haven't returned anything, we haven't exited out of the program, we're just going to do dupes.addNum. Right, we're going to put our value in the set. Because remember, a set cannot contain duplicates. Right? So every value in a set, in Apex and every programming language, just like mathematics, is a unique value. So we're going to say return true. Or excuse me, return false. All right, and this should pass. Dupes.contains num, return true, dupes.add. So same thing as we did before, but we're just iterating through things one time. And we have added a set, so we're using hashing to put in that set so we can retrieve values at constant time instead of having a second for loop to iterate over them. So let's compile this. All right, and let's run solution 2. All right, so that one passed. And just to see something, because I was testing this earlier and I thought it was kind of interesting, we're going to run, the run contains duplicates. All right, and I don't ever want to put too much stock in the Apex test runner, but let's run that again. And you'll see a pretty consistent pattern here, right? Solution 1, 34 milliseconds, even doing this really tiny array, right? It's significant, right? We are 3 times faster by using a set. That's how long our tests are taking to run. Let's run it again. Look at that, 51 versus 11 milliseconds. So you could see, I mean, these are significant differences in our algorithm. And I got, granted, like a user is never going to notice 11 milliseconds versus 51 milliseconds. But if that set contains 1,000 items, 10,000, right, they will. And this is an important part of bulkification. And Salesforce, I mean, I feel Salesforce developers, right, we invented that word, bulkification. But too often we use it only to refer to being able to handle n number of records and not managing the 2 other really critical governor limits, which can be your CPU time and your heap size. And I tell you, almost any time in my life I have seen a governor limit error related to exceeding CPU time, nested for loops were at the bottom of it. So save yourself that headache and just, if I always joke, like if I could eliminate all nested for loops from the Apex code bases of the world, like it's been a life well lived. All right, let's do a third. Well, you know what? Let's before that, let's test the next solution. We're going to test it in LeetCode. Okay. And I'm going to go to JavaScript because I have a... So you can see now we've done this same solution in JavaScript, and I've also included this solution in the GitHub repo for this video. But So right, we're going to do the same thing. We're going to create a set. We're just going to, if set has nums I, return true, return false. And let's submit that one. And unlike our previous Java implementation, that should pass. So there we go. So that's what it would look like in JavaScript. And I wanted to throw that up because I think more and more often it's expected, right? As a developer in this industry, you're very comfortable with Apex and you are very comfortable with JavaScript. And last solution. This is, so in fact, before we go to the last solution, let's go back to this and let's talk about our runtime. Contains duplicates. All right, so this is a constant time solution. This is O of n, right? So if the list size nums, if nums grows, right, it's that many, potentially that many more steps, right? If there's 1,000 things, it's maybe 1,000 steps. But that's way, way better than quadratic time, right? So this is going to grow in constant time, right? So if we had 10 steps, it took, or excuse me, in our previous solution, if we had, say, a list with 10 items, it could take 100 steps, right? This solution, if we have a list with 10 items, it could take 10 steps. If we double it to 20, it could take 20 steps. Our previous solution at quadratic time, right, that could take, 400 steps. So you could see how an O of n solution is much, much better than a quadratic. So this would be what you really want to do in an interview, and be able to articulate not just that you're solving this, but why this is better. Why this particular solution is better than our previous, the brute force, the naive, the quadratic time solution. And we're going to do one last solution I'm going to show because it is worth, you're probably going to use it less. This is O of n log n, and I'm not really going to get into that one because I haven't done a video on O of n log n. So it's way better than quadratic time, but not as good as our previous one at constant time. Because this one is going to use sorting, right? So we are going to do, so we passed in nums, and I'm going to say nums.sort, right? Okay, and we're just going to use the built-in Apex sorting method because why wouldn't you? Okay, but we've sorted that, and so that was one additional step. So the sorting algorithm had to go in and touch all of the items in our array. Now let's do another for loop. For integer I is less than nums.size again. All right, I++. But now because things are sorted, I can just say if nums I is equal to I plus 1, because, let's go back up and let's look at this. Where did I put my now? So this would now be sorted, right? So it would be 1, 1, 2, 3. So because everything is sorted now, we can just say, hey, is the value next to me the same? If it is, we know there's a duplicate. If it's not, we know that we could continue on and we have not found a duplicate yet. So return true. Otherwise, let's go down here and return false. All right, and I want to make sure did I uncomment out my test class, test method. Whoops. All right, come on. Okay. And turn false. Control shift. Let's deploy everything. Okay, let's run all tests. I didn't want to just run solution 3. Oh, index out of, oh, I know what I did. Index out of bounds. Right, because I am comparing it to the next value. So I got to the end and I tried to touch a piece of memory where there was nothing there. So what we want to do for this one is -1. Shift F9. All right, now let's run all tests. Okay, and again, take a look at that, right? Actually, this time the 15 milliseconds, 10:52. Let's run them again. Okay, so you can see once again our constant time and our log-n solutions, for what it's worth, in our test runner are running significantly faster. We're seeing 3, 4, 5 times those tests running faster because they're testing faster algorithms. I will point out, so if you're curious, if you want to see more, I've also in the repo for this video, I'm going to add in some, there also are some contains duplicates, right? There's the JavaScript solutions. You got your brute force function and a function using a set, using hashing, just the best data. So again, this is, I hope this was useful. Please let me know in the comments. And I'm just clicking all over my screen there, and I don't know why. Let's leave it up here. I hope this was useful to you. Please let me know in the comments. And if you take a second and give it a thumbs up, give it a subscribe. And let me know if you want to see more videos like this. Take care, everybody. Keep practicing, and I'll see you next time.